everyone, this is Ms. Hess, and I'm going to give you a quick overview of the Conservation of Mechanical Energy Lab. I know this has tricked up a couple people. I'm just going to go over the data and how you're collecting the data, so this is going to be pretty quick so I can get it all in the 5-minute time limit I have for making these videos. You notice that I'm on the organization. Let me get back to the directions. When you pull up the lab, there's a couple things that are a little bit confusing, but once I explain it, hopefully it's not as confusing. You have this line that you can move back and forth. I would place that line right at the bottom of your spring. So wherever you want to count the bottom of your spring, if you want it to be this last coil or the hook, wherever it is, line up that line and move your tape measure to the bottom of that line. When they talk about your height, your initial height, and your initial the ground in this first section, so you have to measure the initial location of the spring to the ground. They're looking for whatever distance you have down here at the bottom where these weights are sitting, so that's going to be your ground. So you're going to want to take a measurement of what that total distance is, and write that down as your initial distance. Then you're going to pick up one of these weights. So whatever you want to mark your initial distance as, if it's the bottom of this, if you think that it's a little bit higher than the bottom of this, then whatever it is, mark that down because you're going to need that later. You're going to put on the 50 grams. You're going to wait till it stops oscillating. You're going to find out where it stops, and that's going to be your stretch spring. Now, notice that on your chart here, your mass is in kilograms, your stretch spring is in meters, but when you look at the lab, what do we have here? We have grams and we have centimeters, so you're going to want to make sure that you have it changed to the right unit, or else your values are going to be crazy. You're going to take your measurement here. Then what you're going to do is you're going to take the weight, you're going to move it up to the top, and remember, for us, this is 0 right here. This is the way to, we have 0 for the initial measurement, and the distance to the ground is whatever you determine it to be. You are going to take the spring back up to the line and let it go. You've got to find the high and low point. Now, in real time, it's very difficult to do, but if you slow it down over here, you should be able to get it as it's falling right before it goes back up. Try to stop it, so you might want to do this a couple times. You can stop it, take your measurement, so this would be 19 or 20, and then let it go again, and then see if you can stop it as it's up and take your measurements that way. So your initial measurements are going to be whatever it is based on from 0. And then you're going to switch and you're going to do it with the other weights that it's asking you to do it with. Now, when you get to your calculations, you'll notice that you need to calculate the force, which is going to be your mass in kilograms times gravity. It's Ag over here. That's going to be your 9.8. And you're going to find out the spring constant, which is right here, which is your force divided by your stretch spring. Make sure that that is in meters, so it's going to be a point something because we're in centimeters. Then you're going to find your potential energy of elastic for the highest point and the lowest point. And you'll notice that we're using 0 right here, and you'll have to add your distance is going to be x, and your spring constant divided by 1/2. Now, the part that I think might be confusing everybody is when you get down to here and you're looking at the gravitational potential energy, which the height is going to be different. So what you're going to have to do is when you're looking at your values that you have for the height of the spring on when it moves, you're going to have to flip your 0 down here and figure out what the height is of that mass at its height, and then at its lowest point from the ground. So that's how you're going to reverse your calculations, and that's how you're going to determine your potential energy based on gravity. Because when we have a spring, when the spring is expanded, there is our greatest potential energy. But when we're talking about in relation to the ground, the higher the object is, the greater our potential energy. And hopefully your data will show that. If you have any questions on this further, just give me a call, text, or email and let me know, and I'll try to walk you through it.